The 5 foods that rebuild your pancreas. What if everything your doctor told you about your pancreas was only half the truth? Not a lie, not negligence, just an incomplete picture that leaves you feeling helpless when you don't have to be. You've probably been told that your insulin-producing cells are dying, that the decline is inevitable, and that the best medicine can do is slow things down with pills or eventually needles. That story is changing right now, and the people updating it aren't selling anything. They're researchers in peer-reviewed journals publishing findings that most clinics haven't caught up with yet. There are 5 ordinary foods, available at any grocery store for just a few dollars, that contain specific compounds proven to do something the medical world once called impossible. They can help your pancreas regrow the very cells responsible for making insulin. And by the time you finish this, you're going to understand exactly how that works. Your pancreas contains clusters of specialized cells called beta cells, nestled inside tiny islands called the islets of Langerhans. These are the cells that sense rising blood sugar after a meal and release insulin to bring it back down. For decades, the medical consensus was clear and final. Once beta cells were damaged, they were gone. You couldn't grow new ones. You couldn't repair the old ones. All you could do was protect whatever was left and manage the decline. That was the textbook, and most doctors still teach from it. But research published over the last 10 years has quietly dismantled that assumption. Scientists have confirmed that the adult pancreas retains the ability to regenerate beta cells under the right conditions. The stem cells are still present. The growth signals still exist. The biological program for rebuilding is still written into your DNA. It hasn't been erased. It's been switched off by inflammation, oxidative damage, and specific nutrient deficiencies that most people never even know they have. That's the most important thing to understand before we go any further. Your pancreas isn't dead. It's suppressed. The difference between those two things is everything. A dead organ can't respond. A suppressed one can and will if you give it the right signals. The 5 foods we're about to go through each work through specific, documented biological mechanisms. They don't just lower blood sugar in a vague, general way. They target the exact processes that are either killing your beta cells or preventing new ones from forming. We're going to count down from 5 to 1, and each food is more powerful than the last. By the time we reach number 1, you'll have a clearer picture of what's actually happening inside your pancreas and what you can actually do about it than most people ever get from a 15-minute doctor's appointment. Number 5 is broccoli sprouts. They look completely unimpressive. Tiny, fragile threads you can grow in a mason jar on your kitchen counter in 3 days for almost nothing. But inside them lives one of the most powerful beta cell protectors ever discovered. A compound called sulforaphane. When you chew or crush broccoli sprouts, you break open the plant cells and trigger a chemical reaction. An enzyme called myrosinase converts a precursor compound into active sulforaphane, and what's remarkable is that broccoli sprouts contain up to 100 times more of this precursor than mature broccoli. You're getting a concentrated dose in every small handful. What sulforaphane does inside your beta cells is nothing short of extraordinary, and it starts with something called the NRF2 pathway. Think of NRF2 as the emergency switch inside your cells that activates every defensive system at once. When sulforaphane flips that switch, the beta cell immediately begins producing an army of protective enzymes, compounds that neutralize free radicals, detoxify harmful chemicals, and reduce inflammation. This matters enormously for beta cells specifically because they are, by design, unusually vulnerable to oxidative damage. Compared to liver cells, beta cells contain roughly 50% less of the antioxidant enzyme catalase and about 30% less superoxide dismutase. They were built for precision manufacturing in a clean environment, not for surviving under constant chemical assault. When blood sugar stays elevated for months or years, the continuous demand for insulin production generates toxic byproducts inside the beta cell at a rate that overwhelms those already weak defenses. The cells are literally worked to death by their own manufacturing process. Sulforaphane shifts that equation dramatically. A study published in Science Translational Medicine found that sulforaphane reduced fasting blood glucose in obese subjects with type 2 diabetes by around 10%, comparable to some first-line medications. But the protective effect goes deeper than just lowering numbers. Chronic inflammation in the pancreas sends a shutdown signal to the progenitor cells that could potentially become new beta cells. The specific molecules responsible, including interleukin-1 beta and tumor necrosis factor alpha, keep the regeneration program locked. Sulforaphane suppresses the production of both of those inflammatory molecules and removes the chemical padlock that's been keeping your pancreatic stem cells dormant. A study published in the journal Diabetes found that sulforaphane treatment increased the mass of insulin-producing beta cells in diabetic models through both protection of existing cells and development of new ones from progenitor populations. 1 to 2 ounces of fresh broccoli sprouts daily, eaten raw and chewed thoroughly, is all it takes to begin activating these effects. Number 4 is bitter melon, a fruit that's been used across Asia, India, and Latin America for centuries as a blood sugar remedy. In the West, most people have never seen one, but modern research has confirmed that the traditional knowledge was backed by genuinely remarkable chemistry. What makes bitter melon unique is that it contains not 1 but 3 completely independent compounds, each lowering blood sugar through a different mechanism simultaneously. No other single food comes close to that kind of multi-target action. The first compound is called polypeptide P, sometimes described as plant insulin. It's a protein that's structurally similar to human insulin and binds to the same receptors on muscle and fat cells, triggering glucose uptake even when the body's own insulin is too weak to get the job done. The second compound is carnitine, a steroidal saponin that has been shown in some studies to lower blood sugar with potency comparable to certain pharmaceutical drugs. Carnitine works by stimulating the surviving beta cells to release more insulin per glucose signal, essentially coaxing more output from a weakened system. A study published in the Journal of Ethnopharmacology confirmed that carnitine increased insulin secretion from isolated pancreatic islets in a glucose-dependent manner, meaning it only stimulates insulin when blood sugar is actually elevated. That's critical. It dramatically reduces the risk of the dangerous blood sugar crashes that some medications cause. The third compound, vicine, improves glucose tolerance through enhanced uptake in the intestines and improved glycogen storage in the liver. But the most exciting discovery about bitter melon isn't any of those 3. It's that compounds in the fruit were shown in research published in the journal Chemistry and Biology to stimulate the actual proliferation of pancreatic beta cells, increasing the number of insulin-producing cells in the islets through activation of the AMP pathway, the same cellular energy sensor that triggers renewal and cleanup throughout the body. There's also a connection between bitter melon and one of the most important hormone systems in metabolic health. The bitter taste compounds in the fruit activate receptors in the gut that trigger the release of a hormone called glucagon, like peptide 1, commonly abbreviated as GLP-1. You may recognize that name because the pharmaceutical industry has spent billions developing injectable drugs that mimic this exact hormone, and those drugs have become some of the most prescribed medications in the world for both diabetes and weight loss. Bitter melon gives you a natural GLP-1 boost every time you eat it. GLP-1 tells the beta cells to prepare for incoming glucose, suppresses the liver from dumping extra sugar into the blood, and has been shown to have direct anti-death effects on beta cells by activating survival pathways that counteract the damage signals from high glucose and high fat. A study published in the British Journal of Nutrition found that bitter melon consumption raised circulating GLP-1 levels and produced faster, stronger insulin responses after meals. Aim for 3 to 4 servings per week, whether fresh, stir-fried, or in supplemental form. We're now in the top 3, and number 3 is a seed with a reputation so ancient it has been called the remedy for everything except death in traditional Islamic medicine. Black seed, also known as Nigella sativa, contains a compound called Thymoquinone that has emerged in modern research as one of the most potent natural beta cell regenerators ever identified. Thymoquinone is a small molecule that moves easily through tissues and penetrates directly into the pancreatic islets. Once there, it performs several actions in combination that create exactly the conditions beta cells need to survive and multiply. It acts as a direct antioxidant, immediately neutralizing the free radicals generated by glucose metabolism inside the cell. Unlike sulforaphane, which builds long-term cellular defenses through NRF2, Thymoquinone provides immediate frontline protection. Together, they create a layered antioxidant shield that works on both timescales. A landmark study published in the journal Pancreas demonstrated that Thymoquinone significantly increased the number of insulin-positive cells in the pancreatic islets. Crucially, these weren't just any cells. They showed normal insulin content, normal glucose-triggered release, and normal structure. They were fully functional new beta cells. The mechanism appears to involve a protein called PDX1, sometimes called the master regulator of beta cell development. PDX1 is the gene that controls the entire program of turning a stem cell into a beta cell. As diabetes progresses, PDX1 expression declines and beta cells begin to lose their identity and their ability to respond to glucose. Thymoquinone has been shown to restore PDX1 expression in beta cells that had begun to fail, essentially pulling them back from the edge and returning their ability to function properly. A clinical trial published in the Indian Journal of Physiology and Pharmacology found that black seed supplementation reduced fasting blood glucose, improved glycated hemoglobin, and increased serum insulin concentrations in diabetic subjects. That last finding matters most. Higher serum insulin means the beta cells are producing more, not just managing what they have. Thymoquinone also addresses one of the lesser-discussed killers of beta cells, lipotoxicity. When fat levels in the blood stay chronically elevated, free fatty acids infiltrate the islets and accumulate inside the beta cells, where they're converted into toxic compounds called ceramides that activate the cell death program. Obesity and metabolic syndrome destroy beta cell mass largely through this mechanism, and it's almost never discussed in routine diabetes appointments. Thymoquinone inhibits the ceramide synthesis pathway and promotes clearance of accumulated fat from inside the cells, removing that trigger before it can fire. Research published in the journal Lipids in Health and Disease found that black seed oil supplementation significantly improved lipid profiles and reduced markers of this kind of lipid-driven cellular toxicity. 1 teaspoon of cold-pressed black seed oil daily is the recommended dose, taken straight or mixed into food. The taste is peppery and slightly sharp. Start small and increase gradually. Number 2 is turmeric. And before you scroll past thinking you've heard this one before, hear out what curcumin actually does that nothing else on this list can replicate. Curcumin prevents beta cells from committing suicide. That's not a dramatic metaphor. It's a precise description of a biological process. When a beta cell accumulates too much damage from high blood sugar, chronic inflammation, and metabolic stress, it activates an internal self-destruct program called apoptosis. The cell essentially decides it's too compromised to operate safely and shuts itself down permanently. Under normal circumstances, this is actually a protective mechanism. But in type 2 diabetes, the conditions that trigger it never go away. High glucose, high circulating fats, and chronic inflammation push beta cell after beta cell past its damage threshold, and the population shrinks through continuous slow attrition over years and decades. Curcumin intervenes directly in this process at multiple points in the death cascade. It suppresses caspase-3, the executioner enzyme that carries out the final stage of cellular self-destruction. It reduces the expression of a pro-death protein called BAX, while increasing the expression of a pro-survival protein called BCL2, tipping the internal balance toward life rather than death. It also reduces endoplasmic reticulum stress, one of the primary internal alarm systems that detects cellular damage and triggers the self-destruct sequence. The endoplasmic reticulum is the compartment where insulin molecules are folded into their correct shape. When blood sugar is chronically high, this folding factory gets overwhelmed. Misfolded proteins accumulate, the stress sensors fire, and eventually they switch from trying to fix the problem to ordering the cell to die. Curcumin acts as a chemical chaperone that stabilizes protein folding and raises the threshold at which that switch gets flipped. Beta cells can tolerate more stress before pulling the trigger. The clinical evidence for curcumin is some of the strongest on this entire list. A randomized, double-blind, placebo-controlled trial published in Diabetes Care followed 240 subjects with prediabetes for 9 months. Half received curcumin, half received an identical-looking placebo. At the end of 9 months, 0% of the curcumin group had progressed to type 2 diabetes. In the placebo group, over 16% had crossed that threshold. Not one person in the curcumin group developed diabetes, while more than 1 in 6 of those taking the placebo did. The curcumin group also showed significantly higher C-peptide levels, a direct measure of insulin production, improved first-phase insulin secretion, and better insulin sensitivity across the board. This was a kitchen spice achieving results that a pharmaceutical company would celebrate if their drug produced them. 1 to 2 teaspoons daily with black pepper and fat is the recommendation. The piperine in black pepper increases curcumin absorption by 2,000%. And because curcumin is fat-soluble, it needs dietary fat to enter the bloodstream effectively. Number 1 is fenugreek seeds. And the reason they earn the top spot is simple. They are the only food on this list that simultaneously addresses all 4 of the major mechanisms destroying your beta cells while also actively stimulating the growth of new ones. That combination doesn't exist anywhere else in the natural food world. Fenugreek seeds contain a unique amino acid called 4-hydroxyisoleucine that exists in no other commonly consumed food on Earth. This amino acid has a direct, targeted, specific effect on pancreatic beta cells that has been confirmed across multiple independent studies. It amplifies insulin secretion from beta cells, but only when blood sugar is elevated. When glucose is at normal levels, 4-hydroxyisoleucine does nothing. When blood sugar rises after a meal, it helps the beta cells produce a stronger, faster insulin response. A study published in the European Journal of Pharmacology found it increased insulin secretion from isolated islets by approximately 50% at elevated glucose concentrations, while having 0 effect at normal levels. That precision is extraordinary and almost impossible to engineer pharmacologically. Fenugreek seeds also contain galactomannan, a soluble fiber that forms a thick gel in the stomach and small intestine after you eat. This gel physically slows down the absorption of glucose from food, flattening the spike that would otherwise hit the bloodstream after a meal. A study in the European Journal of Clinical Nutrition found that fenugreek reduced post-meal glucose spikes by 20 to 30%. Multiply that across hundreds of meals per year, and you're talking about a dramatic reduction in the cumulative glucose exposure that is slowly poisoning your beta cells every single day. Less glucose flooding in means less emergency demand on already stressed cells, less oxidative damage being generated, and more time for the cells to rest and recover between meals. This is protection through reduction of the primary source of harm, not just damage control after the fact. The regenerative compound in fenugreek is called Diosgenin, a steroidal saponin that activates something called the Wnt signaling pathway inside the pancreas. The Wnt pathway is one of the fundamental developmental pathways in the human body, and it controls cell growth, identity, and differentiation. In the pancreas, when the Wnt pathway is active, progenitor cells receive the biological signal to divide and develop into functional insulin-producing beta cells. When it's dormant, which happens progressively with age and chronic metabolic stress, those progenitor cells sit idle even though they're fully capable of becoming new beta cells if given the right instruction. Research published in Molecular and Cellular Endocrinology found that Diosgenin stimulated beta cell proliferation and increased insulin content in newly formed cells through exactly this Wnt mechanism. It doesn't just stimulate indiscriminate growth, it directs new cell development specifically toward the insulin-producing cell type your pancreas is running out of. A comprehensive review published in the International Journal of Molecular Sciences analyzed every available human clinical trial on Fenugreek and diabetes across studies conducted in India, Iran, Egypt, China, and Bangladesh. The findings were strikingly consistent. Fenugreek seeds reduced fasting blood glucose by an average of 15 to 20%, reduced glycated hemoglobin by approximately 1 full percentage point, and improved beta cell function indices in the majority of subjects across every study. A separate study published in Nutrition Research went further and analyzed actual pancreatic tissue after extended fenugreek consumption, finding measurable increases in the number of insulin-positive cells, more insulin content per cell, and critically, improved first-phase insulin secretion. That first-phase response, the rapid burst of insulin in the first 10 minutes after blood sugar begins to rise, is one of the very first functions lost as diabetes progresses. Its recovery is considered one of the most meaningful signs that beta cell function is genuinely being restored rather than just artificially stimulated. The practical protocol is straightforward and affordable. Soak 2 teaspoons of fenugreek seeds in water overnight, then drink the water and eat the softened seeds first thing in the morning before breakfast. With breakfast, eat 1 to 2 ounces of fresh broccoli sprouts. At lunch, add 1 to 2 teaspoons of turmeric to your food with black pepper and a healthy fat source. In the afternoon, take 1 teaspoon of black seed oil straight or stirred into something. 3 to 4 evenings per week, include bitter melon with dinner, and on the other nights, drink a cup of fenugreek tea made by boiling the seeds in water for 5 minutes. This schedule delivers all 5 compounds across the day in a way that provides sustained activity rather than one large dose. The total daily cost is minimal. A pound of fenugreek seeds costs $3 to $5 and lasts for weeks. Broccoli sprouts can be grown at home for almost nothing. These aren't luxury supplements or exotic treatments. They are ordinary foods that happen to contain specific compounds capable of doing something extraordinary to a pancreas that the world told you was beyond rescue. Your pancreas is not beyond rescue. It is suppressed, starved of specific signals, overwhelmed by damage it was never given the tools to repair. 5 foods. Every pathway that was quietly killing your beta cells is now targeted. Every signal that tells the pancreas to rebuild is now activated. The cells are waiting. Give them what they need and let the biology do what it was always designed to do.